Hello everybody. We got another video for us today revolving around functions. Today's a pretty straightforward day where you're going to be working with function tables, and really it's just plugging in a variable and finding the other one. So it's almost like the second half of what we were doing when solving for systems. So it's stuff that you've seen before, just in a little bit different context. So with function tables today, you're going to be seeing problems like this. Fill in a table using this function rule. When you see this function rule statement, you're talking about a function rule, you're just talking about the equation. That's all it is. Your function rule is the same thing as an equation. It's just the rule that all of the variables that are plugged in will follow. So when you take your x values one at a time, you're going to substitute them in for your x. That's all you're doing. Each table is just having you do it a couple of times. So where we're going with this is we're going to start to see how these tables work. And then we're going to kind of go backwards. We're going to see how these develop into lines and equations and coming up with these function rules. So what we're looking at right now, you're going to take the 3 and plug it in for x. So instead of y equals 3 plus 2x, you're going to have y equals 3 plus 2, not 2x, 2 times 3. And then this is just order of operations. That's all this is once you have that variable plugged in. So I've got to multiply my positive 2 and my 3 first. So then I'm looking at y equals 3 plus 6. And then 3 plus 6 is going to be 9. On Alex, then, you're going to take 9 and type 9 into that box. Then you're going to do this exact thing over again with an x of 4. You're going to start over. You're going to take your your x equaling 4, and you'll have y equals 3 plus now 2 times 4. And you'll do that again. And all that's going to happen, you're going to multiply here first, and you're going to see it's y equals 3 plus 8, because 2 times 4 is 8, and your y in this case will equal 11. So then you would write an 11 over here in that box. That's all that's happening on these first few problems. I think the first 4 problems are like this. Something that's going to look a little different, is going to be these problems. They're asking you to do the same thing. Again, the function g is defined by the following rule. Complete the function table. Same table, same situation, but you notice we don't have a y and an x anymore. We don't have a y equals 4x plus 1. We have this g of x. All that is a way that we write our function rules. It's a function g in terms of x. So all it's saying is that the variable that's in that little parentheses is going to be the same variable that's in the equation. It's just saying that, hey, for the unknown pieces of this variable g, for this equation g, I'm going to have a variable x in there. Looks confusing, might sound even more confusing. It doesn't change what we're doing. The g of x is just like a y. It's your output. That's all it is. Okay? So when we go through the same steps, you're going to take that x value, plug it in for the x. So now instead of g of x, and that's how you say that, g of x, instead of g of x equals 4x plus 1, I'm going to have g of x equals 4 now times negative 5, and then plus 1. So then again, just following your order of operations a few times over. 4 times a negative 5 is going to give you now g of x equals negative 20 plus 1. And then negative 20 plus 1, be careful, it's not going to be negative 21. It's going to be up towards 0. It's going to be g of x equals negative 19. And just like the last problem, that's what you would put in that box. So you'll do that 1, 2, 3, 4, 5 times, same exact process, and you're going to go through order of operations with this variable changed out for the value in the table, and then plug it in to these spots. That's all that's happening with the tables. So your first 4 problems are that same thing. Okay? Now the word problems are really a little bit quicker than that, because it's really just like taking one of these pieces. These word problems, we hate word problems. it's really just like doing one of them. They're going to give you something to plug in. Let's look what we're talking about here. So Manuel received a $40.25 gift card for a photo center. He used it to buy prints that cost 25 cents each. The remaining balance, B in dollars, on the card after buying X prints is given by the following function. The question here, okay, number one rule and what we're looking for with word problems, it doesn't change. What are you being asked to find? The question is down here. What is the remaining, that's a bad box, what is the remaining balance on the card if Manuel bought 20 prints? Okay, so that 20 prints is going to come in. With the number one question we always see here, what do I plug in? I don't know what goes where. There's numbers all over the place. When we get to building these functions from a word problem, then these are going to mean something a little bit more important for us. Right now, they're just telling you how this function came to be. It's a $40.25 gift card, so that's right there in the equation, and it's 25 cents a piece, or $0.25 for each print. So he's spending $0.25 every print he gets. So with that equation, we're now just going to plug in our variable. One thing that's important, one thing to notice, they're telling you that X stands for the number of prints, and then they're asking about a certain number of prints. So that number 20 is going to go in for X. Okay, 20 is going in for X because 20 represents your prints. Okay, X represents your prints. So all we've got to do here is basically just one step of the same problems up above. To fill out a whole table, you had to do this 4 or 5 times. Do one word problem, it's just going through it once. So 20 is going in for X because X represents the prints. So your new equation, the balance in terms of X, is equal to that original $40.25 minus 25 cents times however many prints he gets. How many prints is he getting? 20. They're going to tell you that. That's the variable you're plugging in. So that's going to be 20. Okay? So then this is the exact same thing as the things we saw above. So negative 0.25 times 20, or negative 25 cents, times 20 is going to be a negative 5, or negative $5. So your new equation then, after order of operations is underway, you're going to have $40.25 minus 5. So all 20 prints cost a total of $5. So how much is left on the gift card? What is that remaining balance? B of X is going to equal $40.25 minus 5. It'll be 35.25, and you want to answer word problems with complete answers. 35.25 what? It's $35.25. They'll probably have the dollar thing in there for you on Alex, but just make sure we're labeling our answers if a label is possible. So $35.25. So really today is full of just taking variables, substituting them in, and finding the leftover variable. Okay, so fill out your tables, get those couple word problems. I think the assignment for today has 8 problems, and it's really repetitive as far as the same couple of steps being taken in a few different types of problems. So good luck. Let myself or Ms. Mickelson know if you have any questions, and keep hanging in there. Let's get this stuff turned in, make sure that we're doing what we can, do your best, and this will be over before we know it. All right, guys, have a great day.